Hello, we're going to go through question 1 from the Physics Paper 1 from May 2018. Press play and then pause before I go through the answers, so at least you have some time to think about what the answer might be. Figure 1 shows a student walking on a carpet. The student becomes negatively charged because of the friction between his socks and the carpet. Explain why the friction causes the student to become charged. Well, let's just take a step back and remind ourselves about the atom. So I'm going to choose a small atom, so in this case it's helium with 2 protons, 2 neutrons and 2 electrons. In the middle we've got the protons and they've got a positive charge, and the coloured in ones can be our neutrons. And then around the outside we've got the electrons with the negative charge. And because they're around the outside, it's the electrons that are able to move, or even better, they can transfer. That's the word to try and use. So explain why friction causes the student to become charged. It's because there is a transfer of electrons. They're able to move from one place to another. So we've got socks that are negatively charged, and the carpet therefore must have given them to the socks. So transfer of electrons from the carpet to the socks. Question 1.2, the student's head is represented by the sphere in figure 2. The student is negatively charged. The arrow shows part of the electric field around the student's head. Draw 3 more arrows on figure 2 to complete the electric field pattern. So one's been drawn for us and we've got to draw 3 more. Now you do need to use a ruler. I don't have access to a ruler on the iPad that I'm using, but we can just replicate the diagram like so. Make sure if we zoom in that the line doesn't go inside the sphere, it's got to go up to and touch it. Now the other thing to draw on there, a clue's been given to us, so we need to draw the arrows going towards the negative charge. If you'd been asked to draw a positive charge, it would have been exactly the same diagram, apart from positive charges the arrows leave, and then the negative charges go towards. For question 1.3, the negatively charged student touches a metal tap and receives an electric shock. Explain why. So let's just draw a little diagram to show exactly what we mean. So keep things simple. We've got 2 objects. One is a negative charge, so that's our student. And the other object is a tap that's made out of metal. Now, the chances are the metal tap will be earthed, and that means that any excess charge that's on there will then get taken down to the earth and taken away. So because it's earthed, this will have 0 volts, and because the student has a charge, there will be a potential difference between them. So let's just, for argument's sake, just choose a number, and let's say that's at 10 volts. So we've got a potential difference of 10 volts. 10 minus 0 is 10. So therefore, as soon as the student touches the metal tap that's at 0 volts, that will then allow the charge to move into the metal tap and then go through the earth wire down to the ground. So if we just have a look at the question again. So the negative charge student touches the metal tap and receives an electric shock. Explain why. So the first point to mention is that there is a potential difference between the student and the tap. And this then causes electrons or charges to transfer from the student. And then the final part is just to state that that then earths the charge. The charge or the electrons go to the ground to earth. And then the final part for question 1.4, some carpets have a thin copper wire running through them. The student is less likely to receive an electric shock after walking on this type of carpet. Suggest why. So let's look for clues. So thin copper wire. Well, what do we know about copper? Well, copper is a metal, and metals are generally good conductors, and in fact copper is a very good conductor. It's used in most electrical appliances. It's a good conductor because it has a low resistance, or we could say it allows current to flow easily. So the student is less likely to receive an electric shock after walking on this type of carpet. Suggest why. So we can say that carpet is a good conductor or has a low resistance. So then if the carpet is there, any charge that builds up will go straight away. So what that means is you won't get the build-up of charge that we had in the previous example. And then if there's no build-up of charge, they're much less likely to get an electric shock. That brings us to the end of question 1. Any questions, please ask.